A very good day I bid to Dr. Syed and my fellow group members who are Mohammad Zakwan, Nur Atikah and Nuryn Nabila. We are from Group 7 and today we would like to present on one of the SPC tools, which is C-chart. In this presentation, we are going to cover three parts, which are the introduction, the application, and the solution or suggestion to solve the issue that we discover from the C-chart. Let's start off with introduction. So, you might be wondering what C-chart is actually. Well, C-chart is actually a graph of the total number of defects which is used to detect non-random events in the life of a production process. In addition, the units involved must be standardized, which means that the defects should be measured of the same metric like size, height, length, or volume. There are a few conditions which bring to when C-chart is used. Firstly, the measurement is involving discrete instead of continuous data. Then, the data is on the number of defects instead of defectives. The sample size is constant across the processes. There are multiple defects per unit, and the data is Poisson instead of normally distributed. Next is why is it used? It is used to determine the average quality level, to monitor and control the number of defects within an item, and to focus on any variations from the average so that we can come up with the solution afterwards. This will help us to assess the management and the operations staff quality performance and identify the acceptance criteria of the product before shipping. We believe that these are important for quality control and to cater customer satisfaction. Next, I pass to Atikah.
For the next part, I'll present on data analysis, which is the application of C-chart by using the example. The data that we use is on the furniture manufacturing. The number of scratch marks on a particular piece of furniture is recorded from the 20 samples. For the first part, we set 5 as the average number of scratch marks, and for the second part, we doesn't set any number for the average. To do the analysis, we must know what are the information given, which is the average number is set equal to 5 and the number of items in each sample is equal to 1. Second, we need to calculate the control limit, the upper and the lower, using the formula given in the slide, which is we get CL equal to 5, UCL equal to 11.71, and lower we get negative 1.71, which is negative values. Thus, we set it to 0. And then we run the data on the Minitab. The variables is scratch mark, and then for the C-chart option, we click on the parameters and set the mean as 5. From the Minitab, we will get this type of chart. We can see that the samples number 3, 7, and 90 lie outside the upper control limit. We conclude that the process is not under statistical control with respect to the average that is set equal to 5. The same step is repeated for the next part when the average is not set to any value. We need to calculate the average manually using the formula given on the slide. Thus, we get the control limit which is equal to C bar equal to 6.55, UCL we get equal to 14.23, and LCL we got negative 1.13, which is set to 0 since it's negative value. To run on the Minitab, we just need to add the scratch mark into the variable since there's no mean are set. From the Minitab, we will get this kind of chart. We can see that all the blue lines is in the range of the red line, which is mean the process is under statistical control with respect to the average 6.55.
Next, I will be presenting about solution that can be addressed to solve the issue. As stated in slide 11, there are 3 points outside the upper control limit. Therefore, we need to establish the revised central line and control limit. To solve the problem, firstly we need to identify the points that's outside the control limit, and then we exclude the point which is point 3, 7 and 19, and then we generate the new C chart. For the result, as point 3, 7 and 19 are excluded, we can see that there are no points outside the control limit. This indicates that the process is under control concerning the average defect is 5.
For the next part, I will be presenting about the alternative suggestion that can be made to address the issue happened in the previous slide. A data chart with data points falling outside the control limits or exhibiting unusual patterns indicate a potential issue. As a way to resolve this problem, we would like to recommend a quality improvement procedure in the process of achieving the target of 5 stretch marks on average per piece. In order to get the desired result, it involves analysing the current process. First, we analyse the process that produces the stretch mark to identify the potential causes of variation and determine if there are any factors contributing to the high average. Next, we identify the root causes. Look for possible reasons for the higher stretch mark values such as equipment malfunction, operator error, or variability in raw materials. Perform a root cause analysis to pinpoint the underlying factors. The third step is by implementing the process improvement. Once the root causes are identified, take steps to address them. This could involve repairing or replacing equipment, providing training to operators, or implementing quality controls measures to ensure consistent raw materials. For the fourth step, continuously monitor the process and track the average stretch mark values over time. Use control charts to detect any shifts or trend in the process performance. This will help evaluate the effectiveness of the implemented improvement. Lastly, review and optimize. Regularly review the process and make necessary adjustments to optimize it further. Engage with stakeholders and gather feedback to ensure that the desired goal of 5 stretch marks on average per piece is being achieved consistently. The goal in reducing the average number of stretch marks per item can be accomplished by implementing this suggestion and maintaining a mindset of continuous improvement. That's all from us. Thank you for watching.